of students, we have seen distance formula and what are the application of distance formula. So what are the application of distance formula? We can use distance formula to check the collinearity. We can use the distance formula to see what is the type of triangle, and we can use the distance formula to check which kind of quadrilateral it is. So let us quickly see how are we going to solve the question. So what is the first, let me know what is the distance formula. So whenever you get any question, first start by writing distance formula. Distance formula is root x2 minus x1 whole square plus y2 minus y1 whole square. You can write down as x1 minus x2 whole square plus y1 minus y2 whole square also. Like, let us see how are we going to solve the first question here. So this is our first question, which says determine if the points 1, 5, 2, 3 and minus 2, minus 11 are collinear. Now collinear means they fall on a straight line. So let us see here, the three coordinates are given, means there are 3 points, whether they lie on the same straight line or not. So if I take here point A, then I take here another point B, now we take another point C here, right? So when they are going to be collinear, when all the 3 points fall on the straight line. Now when you are learning collinearity, you have seen that it's not necessary. I don't know which coordinates I have to keep it for A, B or C. So what you can check here, sum of distance of any two lengths, AB, BC, AC, these are the 3 lengths, right? So whether it is AB plus BC equals to AC, or if it is AC plus BC is equals to AB, or it can be here AB plus AC equals to BC. Now, if sum of two length is equals to the third length, then all the 3 points are going to be collinear. So let us first find out the distance between these 2 points, right? So first let us take here AB. Now, if I take this point as A, this point as B and this point as C, right? So let us see here what is given AB. Now, if I substitute values here, 2 minus 1 whole square plus here 3 minus 5 whole square, right? Because I am using here coordinates of A and coordinates of B, right? So when you are using this, I have used just the distance formula. What is 2 minus 1? It will be 1 square plus minus 2 whole square. Make sure you are writing the bracket here, because it's a negative value, whole square will become positive. So this is 1 plus 4, which is root 5. So what is the distance between A and B, or length of AB? It's root 5 units, right? This is your first result. Then let us find out the distance between points B and C, or BC length. What is going to be this here? Now what are the coordinates of B? Coordinates of B is 2, 3 and coordinates of C are minus 2, minus 11. So let us substitute here. If I take B2, x2 minus x1, so minus 2 whole square plus minus 11 minus 3 whole square. Now like signs, values are always going to be added. So if I add these two values, it will become minus 4 whole square plus minus 14 whole square, right? So after that, if I do further simplification, it is 16 plus minus 14 whole square will be 196. What is the total value here? 12, 10, 11 and here 212. Now you can write down the simplest form of 212, right? What is going to be the simplest form? Check here. Do the prime factorization and check what is the simplest form of 212. So it is 106, it is 253. Now here 53 is a prime number. So what is going to be the simplest form? 2 root 53, right? What is the last length I have to find out here? So this is your length of BC, which is the second length. You found AB and then you are calculating BC. Now the third length is going to be AC. Now what are the coordinates of AC? If you see here, A coordinate is 1, 5 and C coordinates are what are the coordinates of C here? Minus 2, minus 11, right? So I can take it here, minus 2, minus 11. Now find out the distance between AC. I'll take x2 minus x1. So minus 2 minus 1 whole square plus minus 11 minus 5 whole square. So what's my answer here? Minus 3 whole square plus minus 11 minus 5 is minus 16 whole square. Now if I take this, it is going to be 9 plus 16 square is 256. What is going to be the sum here? If I take here 6 plus 9, 5, it will be 6 to 265. Now again do prime factorization to check here what is the simplest form. 5 5s are 5 3s are. So this is already 53 is a prime number. So root 265, you can't do the further simplification. Now I got all the three lengths. So first let us write down here ABB got it as root 5 units. BCB got it as 2 root 53 right here. And what else did we get it here? 16, it's a AC, which is root 265. Now if you will see, if you add any two lengths, we are not going to get the third length, right? So what can we say here? You know that root 5 plus 2 root 53 cannot be equals to root 265, right? What is the other case here? 2 root 53 plus root 265 is not equals to root 5. Or what is this? Another one, the last case, if I take it here, root 5 plus root 265 is not equals to 2 root 53. So this shows that hence ABC are not collinear. AB and C are not collinear. Right, so this is the way to check the collinearity. We are going to check all the three possibility, right? So what is the next question? Let us see the distance formula. What is the application of distance formula? Next one, next question is your show that the points, so they have given the 3 points here, and you need to check whether the given coordinates are for equilateral triangle or not, right? So for equilateral triangle, you know that what is the property of triangle to be equilateral triangle? All the three length of all three sides should be equal. So let us first draw a triangle because the three coordinates are given, right? So I can take it as here those three vertices as A, B, C, and write down what is the first coordinates A comma A. If I take B as minus A comma minus A and C as minus root 3A comma root 3A. Right, so these are the three coordinates. I need to find out the length between these two vertices. That means here what to find here? To find is find out the length of AB and BC and AC, and if all these three lengths are equal, then you are these vertices are representing equilateral triangle. So what are we going to do it again? We are going to use here distance formula. So let us write down first distance formula. One time you all need to write down in any of the subjective question. Objective question you don't need to write down. Okay, so this plus y2 minus y1 whole square, right? Now first let us take the length of AB. How are we going to take the length of AB here? It will be root, right? So I can take minus a whole square. You can take it as a minus minus a to b also you can take it. You can take the coordinates of a as x2, y2 and coordinate b as x1, y1, right? Then here minus a whole square, right? They both are negative, so you are going to add it here. Minus 2 whole square plus minus 2a whole square. What is the answer here? Minus 2a whole square will become 4a square plus 4a square will be under root a 8a square. Now 8, if you know that 8 simplest form is going to be here there is a perfect square, so you can write down as 2 root 2a, right? So these many units, it's the length of AB. This is the length of AB. Now the next one, if I take it here, what is the next length I need to find out here? Let us check here BC, right? Now the coordinates of BC are here B to C. So if I take it here, minus a minus root 3a minus of minus a will become plus a because it's x2 minus x1 plus root 3a, and the negative of negative will be positive a whole square, right? Now you need to be careful here. I need to use here a plus b, a minus b whole square identity. So can I rearrange this to make it a minus b whole square plus root 3a plus a whole square. So what are the identities we have to use here? A minus b whole square and a plus b whole square. What is a minus b whole square? A square plus b square plus 2ab minus 2ab, and a plus b is going to be plus 2ab. So this is a square plus b square minus 2ab, and this is a square plus b square plus 2ab, right? So whatever identity you are using, you must mention here. After that, if I do the further simplification, a square plus root 3a whole square minus 2 times a times root 3a, right? Then plus, because there is a plus sign, so I can directly open the bracket. There won't be any change in the sign inside the bracket. So I can write down directly. If there is a minus sign, you need to compulsory use bracket, right? Or I can leave these values in the bracket, and next step I can open the bracket. So this is root 3a whole square plus b square, which is a square, then plus 2 times root 3a times a, right? And square bracket close. Now do the further simplification here. There is a plus sign, so I can open the bracket here. Plus root 3 into root 3 will be 3a square, then minus 2 root 3. First write down the numerical value, and a into a, if you'll see here, a into a will become a square, right? So I'll write down here 2 root 3 a square plus, because in the middle there is a plus sign, no change of sign inside the bracket. So it will become 3a square plus a square plus 2 root 3 times a square. Now if you will see, this is the same value, one with positive, one with negative. So it got cancelled, and after that you are left with 3 plus 3 6, and there's no coefficient, so you take it as 1. So it's going to be total 3 plus 3 6 plus 1 7 plus 1 8. It's going to be root 8 a square, and the simplest form of that is going to be 2 root 2a. So what is your value of BC? 2 root 2a units. Now if you will see, AB is equals to BC. Now let us find out the third length. If that is also 2 root 2a, these are going to be the vertices of equilateral triangle. Now what do I need to get it here? The third side, which is AC length. Now let us see here. Let me take this triangle so that I can use this triangle to solve the further AC part here, right? So I'll use the same triangle vertices to find out the length of AC, correct? Right. Always draw the triangle so that it's easy to refer the coordinates also. So what is the length of AC here? I'll take C as x2, or I can take here as x2 y2, so that I don't need to, I'll not get any negative sign here. This can be x1 y1. So it's going to be here a minus of minus root 3a. You can write down like this also, or you can write down directly a plus root 3a plus a minus root 3a, right? It's a whole square. Then after that, if I open this bracket, a plus root 3a square plus a minus root 3a whole square. Again, if you see, it is in the form of a plus b whole square and a minus b whole square. So if do it here, use it, a square plus b square, which is root 3a square, plus 2ab, 2 times a times root 3a, then a minus b whole square, it's going to be here. This is in the bracket. This is another bracket, a square plus root 3a. This is going to be whole square. Okay, use bracket because there are two bases, so we must write on here whole square. Minus 2 times a times root 3a. Now again, you are having the same value with different sign. So it will get cancelled, but before that let us open the bracket, right? So first a square root 3a into root 3a will be 3a square. Then here plus 2 root 3a square. Now because there is a plus sign, no change in sign inside bracket because it's multiplying with positive value only. Plus a square plus root 3a into root 3a will be 3a square minus 2 root 3a square. Now look at here, it is the same step here, same values will get cancelled, and at the end you are left with again here 3 plus 3 6, and here there's no coefficient here, so it is going to be 1, right? So 3 plus 3 6 7 and 8, so again it is 8a square, which is simplest form is root 2 root 2 a units. So you got AC length also as same. Now here observe this, AB length you got it as 2 root 2a, then BC length also you got 2 root 2a, right? And AC length is also 2 root 2a. So you can write down here, therefore AB is equals to BC is equals to AC, which is equals to 2 root 2a, right? Therefore, what was the question here? These vertices are representing the equilateral triangle. So you'll always conclude your answer. So you'll write down here, therefore, the given vertices represent equilateral triangle, right? Or are the coordinates of equilateral triangle, right? You got this. So this is another application of our distance formula. Now let us see, there is another case where you can use distance formula, where you are going to check the type of quadrilateral, right? Now what are the different types of quadrilateral? You can get it when you are using vertices. First thing, the four coordinates will be given. So you can get a parallelogram, you can get a rectangle, you can get a square or rhombus. So what is the first one? For parallelogram, again for any quadrilateral, remember you are going to find out the length of four sides. Now it's written which kind of quadrilateral is formed if you are using these given coordinates. Remember, whenever four coordinates are given, I'll take it in the order A, B, C, D or PQRS, right? Do not change. You can't take random vertices for the different these naming should be given in the same order, in the correct order, correct? So let us draw first a quadrilateral here. Any, I don't know which kind of quadrilateral it is, so I'm just drawing a rectangular shape, but you are not going to consider it as a rectangle. I'm just drawing it so that I can mark the vertices. So what is the vertex here? The first A vertex, if I take it as minus 3 comma 1, this is 3 comma 1, C is 0 comma 3, right? And D is minus comma minus 4, minus 1 comma minus 4. Now other than that, so that means I have to find what will be this. I have to find out the length of four sides, which is AB, BC, CD and AD. That means length of all the four sides of the quadrilateral. Other than that, to find out the type of quadrilateral, you will always find out the length of the diagonal as well. So what is the length of the diagonals here? BD and AC, right? So here I can take the BD and AC length also you are going to find out. Okay, so here what else? AC and BD. That means you have to use distance formula 6 times to find out these 6 length, right? So first let's start with writing distance formula, that is x2 minus x1 whole square plus y2 minus y1 whole square. You can take it as x1 minus x2 plus y1 minus y2 also. You can change the order, right? So first let us start with the first length. If it is the length of AB, right? Let us take AB, that is going to be here 3 minus of minus 3 whole square plus 1 minus 5 whole square. If you do the simplification of bracket here, 3, this negative and negative will become positive. So it's a 3 plus 3, which is 6, 6 square, plus 1 minus 4 is minus 4 whole square. That is nothing but 36 plus 16, which is going to be root 52. Right? Now root 52, how are you going to write down in the simplest form? 13 fours are 52. Either you do prime factorization or you can directly write down if you know. See, yeah, 13 fours are 52. 4 is a perfect square. So what is going to be the length if you are calculating here? It is going to be 2 root 13 units. Right? There's no meter, centimeter. So we just write down the length as 2 root 13 units. Right? Now after that, calculate the length of BC. So what is going to be the length of BC here? BC length B2C. So I can write on here 0 minus 3 whole square plus 3 minus 1 whole square. Minus 3 whole square is going to be here minus 3. 0 minus 3 is minus 3 plus 2 square. Minus 3 whole square, not cube. This is square. So it is going to be 9 plus 4, which is root 13 units. Now, what is the next side length here? CD length. CD length, again you can take coordinates of C and D. So I can take it here. Either you take minus 1 minus 0, or you can take 0 minus minus 1 also. I am taking minus 1 minus 0 whole square plus minus 4 minus 3 whole square. Right? Now what you will get it here, minus 1 minus 0 is minus 1 whole square plus minus 4 minus 3 is minus 7 whole square. What do you get it? Minus 1 whole square, 1 plus 49, which is root 50. Now root 50 is nothing but 25 twos are. You can write down, other than finding prime factorization, you can write down like this also, right? 25 times 2 is root 50. So 5 is the perfect square, 5 root 2 units. Correct? You see this? After that here, what is the length of AD? AD length, if I calculate here, AD length can be minus 1 minus of minus 1 whole square. Right? Sign will change here. And after that here, plus what is the another one here? Minus 3. We are getting AD length. So minus 3 minus minus 1. Here it's going to be 5 minus of minus 4 whole square. Right? Which is equals to minus 3 plus 1 whole square plus 5 plus 4 whole square. Just be careful while doing the calculation to avoid any calculation mistake. Minus 2 whole square plus 9 whole square. 9 square, right? Which is 4 plus 81, which is going to be here. 81 plus 4 is root 85 units. Right? Now here 85, if I take it, it's going to be 5 ones are, 5 sevens are. It is nothing but a simplest form. It is already in the simplest form, correct? Now after that, what do I take here? What is the length do we need to calculate here? We need to find out the length of the diagonals, right? Let us see here. Let us take the length of the diagonals, which is AC and BD, right? So here, right, so here if I take here AC length, which is one of the diagonal, correct, this length is AC length, which is root, if I take 0 of minus minus 3 whole square plus 3 minus 5 whole square. Right? If you do the simplification, negative of negative 3 will be positive 3. It will be 3 square plus, this is minus 2 whole square. How much you are getting it here? Root 9 plus 4, which is going to be root 13 units. Right? After that, what is the last length we need to calculate here? I can calculate the length of BD, which is the other diagonal. Let us take here BD. We can take here 3 of 3 minus 1 whole square plus 1 minus of minus 4 whole square, right? Which is going to be equals to 3 plus 1, which is 4 square, plus 1 plus 4, which is 5 square, right? You are getting both positive numbers. So 16 plus 25, which is equals to 141 units. Now, if you will see, you are not able to identify any specific type of quadrilateral. So first, let us first write down all the length. Here, AB is going to be equals to here. How much? 2 root 13 units. So 2 root 13 units, right? Then BC is nothing but, here BC is root 13 units, right? BC is root 13 units. Then CD is 5 root 2 units. CD is 5 root 2 units. And then what is the length of AD? Root 85. Length of AD is going to be root 85 units. And then AC length, if you will see here, AC is root 13 units. And here after that BD is root 41. Now 41 is already a prime number. You can't do further simplification. Units, correct? Now, do you see here opposite, any two sides are equal, opposite sides, AB is equals to CD? No, AB is not equals to CD. Is BC equals to AD? BC is also not equals to AD. Do we have AC and BD length equal? Not, so you can see that none of the sides are equal. So BC, AB is not equals to BC, is not equals to CD, is not equals to AD. Similarly, here AC is not equals to BD. Right. So what are the questions they were asking here? They were asking name the type of quadrilateral form, if any, by the following points and give reason for your answer. So we have observed that we are not able to get, it is just a quadrilateral, because if you are taking a parallelogram, opposite side should be equal for rectangle and diagonals are not equal. If you are taking a rectangle, opposite sides are equal, diagonals are also equal. And if all the four sides are equal, it can be rhombus or square. And if the diagonals are not equal, it's a rhombus. Diagonals are equal, it is going to be a square. So we don't find out any specifically here the type. So therefore ABCD is a quadrilateral, not to any specific quadrilateral, right? Hope you now the next question here, question number 4 is, if P is 2 comma minus 1, Q is 3 comma 4, R is minus 2 comma 3, and S is minus 3 comma minus 2 be the 4 points on a plane. Show that PQRS is a rhombus but not a square, right? So it is a rhombus means, let us first try to draw here the rhombus part, and we'll see that here why, whether it's a it is only a square but not a rhombus, correct? So let us first here draw rhombus. Rhombus means, what are the properties of rhombus? All four sides are equal and diagonals are not equal. So let us take here PQRS, right? Now the four coordinates are given. It is 2 comma minus 1, here 3 comma 4, then R is minus 2 comma 3, and here it is minus 3 comma minus 2. Then after that you are going to find out the length of diagonals also. What are the diagonals here? QS is one of the diagonal and the another diagonal is PR, right? So I'm going to find out all these length. How are you going to solve it? Let us see here. Again, whenever any quadrilateral based questions are there, you are going to find out the length of all those four sides and two diagonals. So the what is going to be the sides? PQ, QR, then RS, then PS, and you need to find out the length of PR and QS, right? Those two are the diagonal. So again, we are going to use here distance formula. What is the distance formula here? Write down one time distance formula before using it. So that is x2 minus x1 whole square plus y2 minus y1 whole square, right? This is the distance formula and we are taking application of distance formula. So let us first start with PQ length. What is going to be the PQ length? Observe the coordinates of PQ there. So P2Q. So I can write down here 3 minus 2 whole square plus 4 minus minus 1 whole square. So 3 minus 2, it is 1 square, plus 4 plus 1, it will be 5 square. What is the answer we are getting here? 1 plus 25, which is going to be root 26 units, right? 26 is 2 into 13. So this is the simplest form. You can't do any further simplification, right? So after that, let us find out the length of QR. So Q2R or R2Q, I can take it here. If I'm taking here Q2R, it can be R minus 2 minus 3 whole square plus 3 minus 4 whole square, right? Now minus 2 minus 3 is minus 5 whole square. Whenever there is a negative value, make sure you are using bracket. Now 3 minus 4 is minus 1 square, correct? Now what is minus 5 whole square? 25 plus minus 1 square is 1, which is nothing but root 26 units. Now in the question they have already written, these are 4 are the points of rhombus. So make sure your length has to be equal. All these length, they have to be equal, right? Because it's already given. After that, let us find out RS length. How to get RS length here? R2S, right? So I can take here minus 3 minus of minus 2 because it is x2 minus x1, right? You can put the bracket also here. Then y2 minus y1 here, it will be minus 2 minus 3 whole square, correct? What is going to be the length then? Minus 3 plus 2 whole square. See here, while opening the bracket, careful with the sign, otherwise you may go wrong there. Minus 3 plus 2 is minus 1 square plus 25, because minus 5 whole square is 25. Then this is nothing but 26 units. So my third length, side length is also equal. Then after that you are going to get here PS length, right? What is PS length? It is going to be here again. Let us find out here P2S, right? So I can take here 2 minus minus 3 whole square plus minus 1 minus of minus 2 whole square, right? You can see that here 2 minus minus 3 plus minus 1 minus minus 2. Now here if I do further simplification, it is 2 plus 3 whole square plus minus 1 plus 2 whole square, correct? 3 plus 2, which is 5 square, plus 1 square, which is nothing but root 26 units, right? So all four sides, it's equal. You have checked that of why all four sides are equal. Now you need to get the length of the diagonal. How do we get the length of diagonal? I have to use PR coordinates and then QS coordinates. So let us take here, continue here, so that we can use here these coordinates to length the diagonals, also the length of the diagonal. So let us first take PR, again use distance formula, PR length. So I can take here minus 2 whole square plus 3 minus of minus negative of negative 1, because you are subtracting y2 minus y1. Y1 is your negative value. Now if I do simplification, it's minus 4 whole square plus 3 plus 1 square. How much is this? Minus 4 square is 16 plus 16, which is nothing but root 32. Now root 32 is 16 twos are 32, right? You can write down as 4 root 2 or do the prime factorization to get the value here, right? 32, if you write down 2 to the power 4, 2 to the power 4 into 2 or 2 to the power 5. Other than that, find out the length of QS. Again for QS also you will use distance formula. It is 3 minus of minus 3 whole square plus 4 minus of minus 2 whole square, right? Which is 3 minus minus 3 will become plus 3. So 3 plus 3 whole square plus 4 plus 2 whole square, right? And after that, what are you getting here? I'm getting here 3 plus 3, 6 square plus 3 plus 3, 6 square. 6 plus 36 plus 36, it is nothing but 72. So it is root 72. Now 12 6 I can do here prime factorization here, or 8 9s are. If I take it here, it is 8 into 9, right? Either you do prime factorization or you keep doing this so that you get the perfect square. 8 I can write down here, 2 squared into 3 squared into 2. 2 and 3 will come outside, so 6 root 2 units. Now do you see the length of PR and QS are not equal? Right here, what do I need to show here? It is a rhombus but not a square. So how will you conclude your answer here? You can write down, therefore, PQ is equals to QR is equals to RS is equals to PS is equals to root 26 units, which shows all length of all four sides are equal. And you will write down here PR is not equals to QS, because here 4 root 2 value is not equals to 6 root 2, right? So how are we going to get it here? This shows because all four sides are equal, diagonals are not equal. So this shows PQRS is a rhombus, right? Not a square. Now you can see that it's already, your answer was already in the question, because show that means you know that you need to reach to that result. So hope you got it, that how are we going to use all these questions using distance formula.
Thank you for watching this video. Please like, share and subscribe. Also, keep practicing.